As the name suggests, a cooling tower is a device that performs cooling. This could be in a process involving machines or presses. It could be the ladles of a rolling mill. Something operates and generates heat. That heat is collected in the water. The water is sent to the cooling tower. In the cooling tower, it is cooled, brought back to its initial temperature, and then returned to the machine or equipment in the process, whatever that may be. This cycle continues endlessly. Now, the way that a cooling tower works is actually quite simple. There is a water distribution system, and beneath this water distribution system, there is fill material. The water distribution system polarizes the water, achieving a state of near perfection. It breaks it up into very tiny particles, so small they can hardly be called droplets, and sprays them onto the fill. The purpose of the fill is to slow down the flow of water. Another purpose is to provide surface area for evaporation and physical contact. It also spreads the droplets out, making them a bit more flat. Thanks to that flatness, the surface area in contact with air increases. Wherever it touches, cooling occurs both through conduction and through evaporation on that surface. 85 to 90% of the performance you get from a cooling tower comes from evaporation. When water changes from liquid to gas, that is, when it turns into vapor, it absorbs 540 kilocalories of heat, even if its temperature doesn't change at all. The heat that water absorbs as it changes from a liquid to a gas provides the vast majority of the cooling performance, somewhere between 85 to 90%. In other words, heat transfer by conduction only contributes about 10% and at most 15% to the overall cooling of the water. The main cooling actually occurs through evaporation. The water you supply to the tower decreases somewhat and returns to the pool due to evaporation. After that, it is sent back by pumps to whatever process, machine or equipment is being used there. While doing this, of course, as I mentioned at the beginning, we break the water into very small droplets. Because there is a forced airflow inside, some of those very small droplets can be carried upward without falling down. Fortunately, a droplet separator system is in place that prevents this from happening. Droplet separators guide moisture-laden air through specially designed bends called passo. This process causes tiny water droplets in the air to impact the vane surfaces. On these surfaces, the small droplets combine to form larger drops of water, which then drip back down into the system, effectively reducing water loss. Droplet separators may seem like they don't serve much of a purpose, but they are actually materials that enable the recovery of a significant amount of water. There is also a mechanical assembly located at the very top. This mechanical assembly is generally composed of a fan, a motor, and, in the case of some specific towers, a gearbox. In construction towers, since the motor and gearbox together form a very heavy load, you wouldn't want to apply that as a point load. You also place the motor outside to protect it from water to some extent. In these types of units, there is also a drive shaft. This mechanical assembly enables air to be expelled vertically upward at a very high speed. As the water flows downward, the droplets come into contact with each other. Cooling occurs through the processes of conduction and evaporation. In fact, it is quite a simple material. There are a few important key points to consider. If you pay close attention to these, you can use it for many years to come without any problems, both in terms of performance and maintenance.